Good evening, everyone. Thanks for taking the time out of your busy days to join us for our webinar tonight. I'm Miriam Druitt, the Marketing Communications Manager with AHDB Pork, and I'm delighted to bring you this evening's webinar. Tonight, we'll be hearing from Nigel Penlington, Head of Environment and Buildings at AHDB, and Mark Jagger, a Fieldsman with Tulip. Nigel will be talking to us about ensuring you have adequate supply of fit-for-purpose water. Mark is then going to talk to us about moving from in-feed medication to water medication systems within Tulip BQP. As Nigel and Mark run through their presentations, which should be around 30 to 40 minutes, everyone will remain muted. However, if you do have a question or comment, please just type this in the question box that should be showing on your screen, and we'll try to address these as many of these as we can at the end of the slides. We'll try to keep the webinar running smoothly, but please bear with us should we encounter any technical difficulties. And if you experience any issues with sound or your connection, you can join the webinar via phone using the details included with your booking email. So without further delay, I'm delighted to invite Nigel to kick things off.
Okay, good evening, everyone. Thank you for joining us. Tonight, in this first stage, I'm going to look at water systems and medication. So we're going to look at the water systems themselves, and then the challenges for when we apply water medication through the water. Also look very quickly at the legislation around water systems, implications of to the application of medication via water, and then finally just the environmental impacts or consequences as we do this. So our water systems are a challenge for adding medication or other products. First of all, we need a good, well-functioning water system, which will get us the correct amounts of clean water to the pigs when and where we need it. The pigs themselves need uninterrupted access to water, so there's no competition, so placing of drinkers, etc. in relation to feeders is critical, as water and feed intake are both aligned. Adding medication or products to improve health adds a new challenge to the water system, which often it was purely designed just to get the water to the pigs. So we need to have a look at these. What are the unintended consequences, and how can we make the whole thing more effectively? Initially, if we just start thinking about survival times of some of the common pathogens that we find around the pig unit, then this gives us an indication as to why we need to keep the water clean and fit for the pigs. So, for example, if we look at swine influenza, that can easily live for up to 32 days. Things like salmonella, 54 days. Swine dysentery, 61 days, and PRRS, 11 days, and the big one is E. coli, which can actually live in a water system for up to a whole year. So whilst we might spend a lot of time cleaning the building, making sure the rooms and everything are really clean, actually we could have all sorts of hidden germs within the water system. So that's why it's also important that we pay a great deal of attention, or equal attention, to the hygiene of the water system. So then if we're looking at our water, is all the water the same? For example, we have bacterial contamination. If we, as we've just seen, there are numbers of pathogens that can get into the water, and the amount that these multiply, or the concentration of them, will vary. We also have the mineral content and hardness of the water. This affects how the water, well, partly the palatability of the water, which is important to check because we want the pigs to drink it uninhibited, but also the interaction of water with anything that we put in it. Yes, we get hardness, we get iron deposits, which can cause blockages in pipes, but also if the minerals are incompatible with the for example, organic acids that we're putting in, then actually some of the chemical changes that are going on may not give us the results that we require. So we need to understand what the water is that we have, and then we need to just think about mains or borehole or other home sources of water. Mains water all comes into or enters the farm as potable, treated to a very high standard, very low levels of contamination, meeting strict criteria which the water companies have to adhere to. However, water coming out of a borehole very often does not benefit from any treatment. It is just basically raw water. And it's very easily also contaminated. If there are any contaminants getting into the borehole, which can occur, for example, if somebody's spreading slurry near it, or where the borehole is located in relation to activities on the surface, then that's important. And whereas water companies will treat their water and take out the contaminants, whether they're nitrates or other chemicals, then actually on the farm borehole that doesn't happen. So it is important that we understand the water that we get from our boreholes. Within AHDB, we've got a number of fact sheets. So we actually have one which goes into a great deal more detail about managing the mineral content of water. Another challenge is actually the distribution system. Is the water getting to the end of the pipes? For example, on pig units, just like the electricity supply, often we find water systems have evolved over the years. And they may even be taken off to other parts of the farm. So, for example, if there's a heavy demand for somebody for a sprayer example, what is that having effect on the pig unit? Or even other big users on your supply line. So we need to just think about what is the supply pressure? Is that adequate to actually drive the water through all the pipes and the network that you have on the farm? As I mentioned earlier, often the pipe works have just grown, evolved, with very little attention paid to the diameter of the pipe, which will affect the flow of water down it. If you just think about a corridor with lots of people in it, then if there's a lot of people trying to get down a narrow corridor, then there's a high pressure and they struggle. If it's wide, then the flow can go easily. So pipe diameter and flow are really critical to make sure that we are supplying adequate levels of water to our drinkers, whether they be nipple drinkers, trough drinkers, or whatever. Then we have to look and question ourselves, are there any restrictions or blockages in the pipe? We mentioned iron deposits, hard water deposits. Very commonly we will see scale, especially in old pipe works, iron pipes, for example, which actually restrict the flow. And, you know, very, very quickly we can lose an awful lot of our capacity. Then we have things like biofilms or slime, which will grow in pipes. Hence, you know, if there's what we are seeing, or we have seen, some quite considerable levels of slime buildup. So it's important that we keep the pipes clean, and we'll talk more about that later. It's being aware of what could be the causes of this and actually preventing any buildup to start with. Often you'll see in pipe work that hasn't been used for a long while, this is where, you know, you'll often see biofilms build up. And then just looking at the drinkers or the troughs themselves, do they have actually the correct inserts in there? There's little small inserts. You use different sizes for different pressures. Same with ball valves. You get red ones, blue ones. Have you got the right one? All these things impact on the flow of water, and it's also important that when you're testing the water on the farm, that you don't do it when pens are empty. Actually do it when pigs are active and there's a number of pigs drinking, and therefore hold the valve open for a while to ensure that you have actually let the drop pipe, etc., clear out before you start measuring. So yes, we're talking about drinker inserts, for example, and very quickly you can just see here on this graph, there's different inserts for different levels of water pressure. Very often, if you're just on a header tank, simple header tank, then if that header tank is only 2 to 3 meters above the water, above the discharge point or the drinker, then you are really struggling for the amount of water, and you need the lowest pressure inserts you can get. You'll be at about 0.2 bar. If you're on the mains, then you'll use the smaller inserts because you could have much higher pressures. And it's important maybe that you have a plumber or somebody just check to ensure that the pressure, to ensure you've got the right ones. So also along this line within AHDB, we've now provided, we've got a handbook which will help people actually design water systems. It takes you through the process from the start, from your supply, whether it's a header tank, whether it's the mains, looks at all the pipe work and the demand, and enables people to actually calculate what diameter pipes are required. So legislation applying to water systems. We don't want to see troughs like this one. This is now redundant, but this is the sort of thing that used to happen, where you had bore valves that could get submerged, and it's very easy for that contaminated water, if that was connected to a pipe, to actually flow back down the pipes and then contaminate other parts. So we have legislation to protect the system and to protect those that are using it. And it's important these are followed. The main ones are the water bylaws, and these apply to the owners and occupiers of all premises with a public water supply, i.e. mains water through a meter. And they protect that supply from contamination, such as backflow, and farms are really classed as a high risk because of the manures, fecal material, chemicals that are used for contamination. And also the waste of water. Water is now a scarce resource, and it has to be conserved and used efficiently. But the key thing is also that they help the system give you good service, and that's where it will pay you benefit, or it will pay you dividends. So there's a very useful handbook which you can get off our website, which will take you through all the stages of the water bylaws as they apply to livestock farms. If you're on your own private supply, then again, there's a private water supplies technical manual and the private water supply regulations. So they're not unregulated. So again, if you get any contamination and it goes back down into the supply source, whether it's a stream, river or borehole, then again, you could be liable. So again, these guidelines or these regulations help protect the water before your farm and then also within it. Cross connections is a common source of cross contamination, where a number of farms and other industries have got themselves in trouble in previous years. So it's important that they're set up that you cannot get your non-potable or your private supply water cannot contaminate the mains water. Hence, you'll see in this diagram, the private supply, the green one, is lower down and the mains one is higher. And there's no way that the water level can reach over the top of the tank and reach that main supply inlet. And the water bylaws, they are regularly policed by the water companies, and it's important that farmers do adhere to them, especially when they're using things like dosers, which Mark will talk about, to add products to the water. Then, as well as just looking at if we're adding things, we need to check that the compatibility of our product is compatible with the water supply. So, for example, organic acids, then different acids work differently with the different minerals that are in the water, and there's a thing called buffering capacity which we'll talk about later. So you need to understand that and make sure that you select the right product for your water, but also for the part of the animal's digestive system where you're trying to have an impact. It is also important that we get the right dose of the product to each pig. So Mark's going to talk about that. And part of this is to also avoid waste, but also to make sure that we actually are reaching our correct levels of medication. If we think about it, on farms, we spend a lot of money with crop sprayers, really precise, able to precisely apply a very small amount of a chemical accurately to the point that we want it. Well, we need to think in the same way when we look at the water system in the piggery. Just finally, looking at the environmental impact, as I mentioned previously, water is a scarce resource, especially in certain parts of the country. And there's growing demand. and some pig farmers are finding it harder to actually get abstraction licenses, etc., to put in new units. So we need to use it efficiently, not make sure that it's waste. It is also a costly product, especially if we're buying it from the mains, but it's not just the cost of buying the water. If we waste it and it gets into the slurry system or the dirty water system, then we have the costs of storage and spreading, which can often be several times the cost of actually purchasing it. But if we're now adding products to the water, we need to think, if there's any waste, where is that going? What's going to be the environmental impact? Hence the reason we need to minimize that waste. So now I'll hand over to Mark, who will take you through the actual application and applying the theory into practice.
Good evening. My name is Mark Jagger. If you bear with me, that's it, we've got it going. For those that don't know me, I'm a fieldsman that's been working within Tulip or BQP for about the last 25 years. The first 22 years I worked just as a growing fieldsman, servicing many of the farms within BQP and Tulip. Over the last 4 years I have been fitting dosers, in our case the Select Doser 640, onto all our farms within the group. And during this presentation, what I'm going to aim to cover is why we moved from in-feed medication to water medication, and then why we also started looking at the cleanliness of our water lines as we went on this route of putting in the medicators. So firstly, really the history and reasons of why we went and did this. The first reason started around 15 years ago. Our retailers that we were supplying, through the customers, they were asking the retailers about our use of in-feed medication and the risks of in-feed medication and the carryover to the finishing pigs that were then going to slaughter. It was also deemed that maybe some of our in-feed medication was prophylactic. So how could we actually medicate quicker? And we felt that probably the quickest way to do this was through the water systems. Our own veterinary department felt that we needed to be changing our methods because it would probably be forced upon us eventually sometime in the future. So how did we originally change? And the original change was looking at all sites, and be it by shed, by row, and looking at the size of the header tank. Some sites had, 7,000 litres of header tank up in the air, and it would be way too much to actually give a daily dose of meds. So we reduced the size in some cases, increased the size in other cases of the header tanks to the right size for the number of pigs, so we could actually medicate if need be accurately. Around 4 years ago, we started trialling, as many did, acids within the water lines. We have maybe a unique problem within the bed and breakfast, is that we supply our acid to our farmers, and a couple of farmers by accident caught themselves with splashes of acid and it burnt them. So there was some health and safety issues starting to arise on farm. So we were looking then on how could we actually deliver acid safely for livestock workers onto these farms. And as a result of that, we were looking for different machines. And as I'm sure all of you are aware, there is the Dosatron, the Medigator, the Select Doser, many different machines. The problem we had was we had then put all these header tanks in, so we needed to select a machine that would actually deliver the correct dose into the line without requiring 3 bar of water pressure, in some cases running on 1/4 bar. We decided to go for the Select Doser 640, and the main reason for that was it doesn't require a massive bar of pressure, but what it does require is a 3-pin plug to drive the machine. And I'll go into the actual mechanics of the machine in a moment. So moving on to fitting the dosers. The first question when you're fitting any doser is really, does the line deliver the sufficient amount of water required down that road, very much as Nigel was saying. And what I'd say to you,
Mark, sorry, it's Nigel. Could you just, at the top of your screen, there's a little orange arrow. Could you just click on that, please, and see if that'll hide that? Brilliant.
Yeah.
Has that done it?
Has that done it? I'll carry on. I think that's maybe done it. What I'd say first and foremost is be very honest with yourself. If you're about to spend a few £100s on a doser, the first thing you want to be is honest with yourself. Is the line actually delivering what it should be delivering? What I came up with was, I'm fairly simple, is can it deliver a litre an hour down that water line at the end of the line for every finishing pig in that building? I would suggest if you're only taking the pigs up to 35 kilos, maybe you can get away with half a litre. And why did I go on that? And this graph hopefully shows you. You can see mid-afternoon peak point of drinking on each day. These pigs were 15 weeks in, 1,000 pigs in each unit. The blue line is one shed, the yellow line is another shed. And they're peaking out at around 750 litres an hour. So if you can get, that's for 1,000 pigs, so it's 750 mil per pig. If you can get a litre per pig, you know that you're more than covering the requirement of water that these pigs require at that particular point in the day. So then we go on to what systems do we use? As I said, some of our systems were gravity fed, but really what do you want to achieve with those systems as well in regards to, are they gravity, should there be gravity, can the doser fit onto them? And in that case, it has to be a select doser because you haven't got the pressure to actually use a medicator or a dosatron. If you've got pressurized, you can use all types of doses. But the important thing at that point is look at the system, check that it can deliver that. And gravity, what we found with many units, as Nigel was saying, is you build ad hoc. You might actually find that your header tank has only got a 20 mil outlet, and you might be trying to feed 1,000 pigs off 20 mil. So you may have to actually go right back to the header tank and actually bore a bigger hole in it to actually supply the water down the line. It's simple stuff, really. The bigger the bore, the more water you can handle and the more you can get down that line. Once you've got the opening, whether you're gravity or whether you're pressurized, we fitted something like this, and I'll talk it through. If it was pressurized, just before the pressure system, before the isolation tap, we'd put a pressure regulator. So we can drop the pressure down to approximately, for a finishing shed of 1,000 pigs, half a bar usually is more than adequate for those pigs. First thing is an isolation tap, especially at this time of year. If you need to take it apart, the one thing you do want to be able to do is stop the water flow. It is a bit chilly. Then, as you can see, the next thing down the line, the water goes that way. The next thing down the line is an inline filter. This isn't to take iron out, but believe it or not, even if you've got mains, you will get a few little bits of solids going down the water line. After the filter, we have our first injection point. And this we use is just for cleaner. You can see the little fittings we've got. This is the injection point. It's just a little saddle, 7.6 millimeter drill hole, and it's clamped on with a pair of pliers. We then quick release couplings to go to our flow sensor. The flow sensor is just this little tiny turbine, so it keeps spinning, hence why we don't want any solids going down there. And as that spins, it sends a pulse up to the select doser. Another quick fitting, so we can release the flow sensor if we get any blockages. And then we have our meds injection point. Exactly the same as that injection point, standard bits of kit. And then off down to, say, 1 or 2 lines that are inside your piggery. If it's just a gravity-fed system, you won't need at this end the pressure reducer. It just goes straight on the outlet of the tank. So That's why we went for this system, because actually it fits all our farms that we require. So, talking about that, what problems did we have to overcome as we fitted the systems in? These are really the two types of problems we had. One was the flow going down the water line. And really, the first thing was the pipe bore. In some cases, the pipe bore was a 20 mil water line, and it just didn't carry enough water for the pigs. Outlets, as I said, on header tanks, some of them were put in with metal that had then corroded, and osmosis was the only way the water was actually getting through all the iron that was around the outlet. In some cases, we actually came to farms where the water line from the header tank to the actual drinking area had been pulled up in the air to allow a tractor to access underneath it. And as a result of which, the pipe carrying the water had actually got to the height of the top of the water in the header tank. So you lost all the pressure and weight of the header tank. And finally, not enough fall in the gravity systems. Amazing how many people had put a header tank in and literally got it only 3 or 4 foot above the drinker height. And when you're running a shed that's maybe over 100 foot long, when you got to the end of the building, there was just not enough fall if the pigs were drinking at the beginning part of the building. So pigs were running out of water. And you'd be surprised how many farms I came to where a pigman would actually admit that they were running out of water. The farmer maybe didn't, because actually the minute you admit it to yourself, you have to accept that you've got to actually put some money into the job and improve the line. Once I started cutting into water lines, the first things that shocked me was biobloom, iron deposits, and general dirt from not cleaning our water lines. And when we looked at it, we hadn't really cleaned water lines within the BQP structure well at all for probably 20 odd years. So there was an awful lot of dirt and rubbish that we had to get out of there. Many bores were unfiltered, so we would have massive iron deposits. We'd maybe used certain medications and then acids, which then caused bioblooms going into the water lines. And in the worst case scenarios, some of these bioblooms got so thick in the summer that actually we just didn't get any water to the pigs, and you'd have to strip the lines out. And again, as I was touching on before, different bores. This graph here are 3 identical sheds with different systems. And hopefully you can see along the bottom axis the days from weaning. So this is day 1 of the batch. This is the litres per pig that the pigs were drinking. You can see that we have 1,000 pigs in each shed, exactly the same size of pen holding 50 pigs, a 5-space feeder and a 5-space drinker for each shed. The first thing that's noticeable is the purple line, which is our pressurized system. And you can see that the piglets are drinking way more in that shed than either of the others. The blue line is what you would class as our average farms that are just a gravity-fed system, 8 foot above the height of the pigs, and just normal gravity going down the flow of the line. 25 mil on both the pressurized system and the Jag drinker pressure gravity. There's another one, the green line, which is 19 mil water, and you can see as the pigs get further into the batch, it's probably not supplying enough water for the requirement of the pigs. Interestingly, all of them were doing a very similar FCR, but where it was a great change was the pressurized system that was supplying more water. The pigs seemed to be hitting finishing probably a week ahead of the 19 mil gravity fed system. So actually reducing your water intake through the quality of your water pipes or the size of the bore can actually affect the length of time your pigs are staying on your farm. Interestingly as well, what we have found, and you can see it here, there was a certain amount of illness. And as soon as we pop medication in, you can see the reaction from the animals, and there was a sudden increase in water intake, bringing them back on track to the growth rate there. But that we are finding as we're looking at these more and more, that one of the questions you want to be asking yourself is, if after 3 days your pigs are going off water, are you starting to see problems in health? Be it enteric disease, respiratory disease, or even strep throat. They asked me to do some sort of benefits of clean water. To me, it's fairly obvious, but actually when you try and Google anything on benefits, in reality, Google tells you nothing. I suppose we should sort of think, well, of course, it shouldn't tell us anything. We all should know what the benefits of clean water are, but there is nothing telling you the benefits within pigs. So I looked to where really there is water problems, water quality problems, and that's maybe Africa. And pigs and humans are very similar internally. And there's some little statistics there to sort of peruse at, right or wrong, that are quite shocking. But the one that I find staggering is maybe the 10% of infants under the age of 5 dying from poor drinking water quality. When we bring our children home from hospital, we always make sure that the water quality is the best we can. And maybe the message we want to take from this is, when we wean our piglets, should we be giving them the best quality water we possibly can to help that little gut, fresh off mum, off milk, to actually grow and continue growing right the way through its life? Should we be preserving that animal? So the main problems that I've found on all farms are, boar is probably the biggest, the lack of filters. We all think that we pull the water out of the ground and it's fine. It usually isn't. It quite often carries E. coli. Some cases it will carry salmonella. Check all that. And if you haven't got a filter, question why you haven't got a filter. Should you be putting iron filters in? Should you be putting UV filters in? That sort of thing. Improve the quality of your water. Lack of cleaning. I think we're catching up with the poultry industry, I'm proud to say, but we need to do more on the cleaning and that side of things. High acid use without cleaning your water lines, high medication use without cleaning your water lines will result in biofilm. Biofilm will then restrict your water to your pigs, which will add length of time that your pigs are in your finishing house. So bear those little problems in mind. Moving on, solutions. I've banged on about the problems. Well, the first one, I keep banging on about it. Boars, please, please, please fit correct filters. It's not free water if it's actually poisoning or slowing the growth of your pigs. You'd be better off on mains. Find the right product to clean your water lines. In our case, we chose what was called Endosan, it is now called Huasan, and we rigorously clean all our water lines. End of the batch, luckily we run a batch system, so we can what we call shock dose, and I've got a couple of little pictures that we send out to all our farmers on how to shock dose their water lines. And then for the first 3 to 4 weeks, we have standard practice that we then put the Huasan down the water line at 25,000 to 1. So you don't use a great deal when the pigs first arrive. But that basically brings that water to a top-notch quality. And it's killing any salmonella, any E. coli, any of those pathogens that Nigel showed on that earlier slide. It's killing them, and we're not giving them to our piglet. If you've got header tanks, regularly clean them between batches and disinfect them, pressure wash them out, and make sure that it is absolutely top-notch drinking water that you're storing in that header tank. I've had farms where they don't empty the header tanks, and when you see inside them, actually the sludge that's in the bottom is quite disgusting. If you are pressurizing the system, have faith in that system. First and foremost, make sure that you buy a pump that you can replace, preferably on Christmas Day, because that's going to be the day it goes down. Or even have a spare, just in case it does. But if you trust the system, cut the header tanks out of line. They really are only going to be a reservoir for your disease. As I said, clean and terminally disinfect the water lines and all the drinkers. It's important, don't just disinfect the main line. Take that Huasan or whatever cleaner you decide to have, right the way down to each nipple, right the way down to each bowl. And I would recommend keeping a maintenance dose going through the line. We have certainly seen benefits in that. And I know the guys, the two people who actually were up for the award from BQP, both of them regularly use cleaners in the line. I touched on what do we do, and we have two little sheets that BQP have that we give our guys within our farms the standing operating procedures. One is for the terminal disinfection, and we put the Huasan down the line at 100:1, and that will, as we like to call it, nuke the line and kill anything in there, including any iron deposits and sludge deposits. It dissolves it, that's why we like it. So actually, it doesn't leave a sludge behind the drinker nipple, it dissolves it and it can pass through the drinker nipple and we got rid of. And then once the piglets first come in, it says for the first 14 days, but we have increased it now to 21 days. We just put that Huasan down the line at 25,000:1. So it is very little cost. It usually works out at something under a penny a pig. So it is very cheap to do. That's my little presentation. I'll hand you now back to Nigel, if I may. I don't know how to do that, so I'll leave Nigel to take over.
Okay, thank you, Mark. That was really useful. Thank you. And just get rid of hopefully that, and we can see the screen. Okay, so some useful tips there from Mark. So yeah, just looking at what is in the water system, or could be lurking in water systems. Here are some results that we've from measuring samples we've taken, and Mark was talking about doing deep cleans, so actually having a real good thorough clean where you to go right through from the header tank right the way through all the filters and to the end point. And here we have the header tank, and here we have the line. Some cases really quite high levels. The red line here is that what's we would consider is an acceptable target level for your piggery, and is the level used by Red Tractor. We're measuring our total viable count at 2 temperatures for grown over 72 hours. First of all, we look at 22 degrees centigrade. This is the temperature where the organisms will grow at room temperature. So what we're looking at is what's growing whilst the water is in the piggery. And the second one is at 37 degrees, where they incubate them for 48 hours. And this is to look to see what levels of bacteria are in there, which would grow within the pig's body, live at body temperature. So in both, we've got quite high levels at the start for both things, but what we can see is actually when we've done our deep clean, then we can get the levels very good in the header tank, but we have seen them starting to creep up in the lines, which is actually understandable because we've still got levels in the header tank which are growing, and then they pass off and down the line. Same at both 22 and 37 degrees. However, we have now got further results where we've shown that actually doing a real good clean, we get the contamination levels right the way down in the header tanks, way lower than the human standard, which is here 100, and way below the acceptable levels that we're looking for. So we demonstrate that you can actually clean the water very effectively, and as Mark says, by continually just putting in a low dose, then actually what he's trying to do is actually recreate the similar to potable water, which again, the water that we get through the taps is treated, and that prevents bacterial build-up in the water system. So when Mark mentioned biofilms or slimes, whatever, when we look at these in the pipe, then they coat the wall of the pipe, and but when we add a sanitizer to the water, then actually we have to give it long enough, sufficient time for it actually to work and eat its way through what it's trying to do. So it needs time to penetrate this thick wall. If we're regularly dosing, regularly treating, then then actually it will work very quickly. If we've never done it ever before, then just like a lot of grime, we have to leave it to soak and actually penetrate. And it needs this time then for it to be effective to kill the contaminants, so that then they fall off and become dislodged and start moving down the flow out through the water when we're flushing the system. So it's important that we do that. So the important thing here is do what the label says and read the label, especially if you change supplier, because concentrations, etc., may differ. Always read the label. Then cleaning the system, as Mark mentioned, just plan your work. First of all, we would say just sit down, draw a map of the system, look for things where there might be dead ends, etc., and then work through it logically and say, right, which is the most effective way to clean this and to get to all the points. Drain and clean all the parts. It is important that you drain them out. It's useful to actually just give the system a good flush before you start doing your cleaning, because then you've got rid of some of the loose debris and the products can be more effective. And finally, use the right product for your objective. Make sure that you are using compatible products. So the key thing is really just pay attention to the detail and clean it right the way through, and you can be really effective. So finally, just to sum up, help is at hand within AHDB. We've been doing an awful lot of work, and I know for Mark at Tulip, they've got guidance as well for their producers, but we now have numbers of fact sheets, booklets and animations, videos, just explaining all the different aspects of water supply and ensuring that you get the best quality water and give the pigs the medication, etc., which they require. So just to conclude, be clear on what you're trying to achieve, understand your water system and your objectives, make sure that whichever products you use are going to do what you need to do. Sounds obvious. Also, know your water. Not all water is the same. Follow the instructions on the label and develop a work plan and keep to it. And as I said before, it's all about paying attention to the detail and get the basics right first. So that's it from us. So now if we hand over, if you've got any questions or comments about anything we've covered tonight, please could you type them into the text box and we'll try and get through as many as possible. In the meantime, I'd like to remind you that tonight's presentation has been recorded and it will be available to watch back on the AHDB Pork YouTube channel in a few days' time. So if we now move on to the questions.
Okay, thanks Nigel, thanks Mark, that's great. We've got a couple of questions through already, so if anyone's got anything else they want to comment on or ask Nigel or Mark, do send those across now in the question box. We've got a few minutes for discussion time, so send them through and we'll get through as many as we can. So to kick things off, this is probably one for potentially Nigel and Mark could comment on. How do we go about designing a new water system to include doses?
Nigel, do you want me to do this one?
Yeah, you go on there. Go ahead, Mark. Yep, thank you.
I think in a perfect world, and if you've got a brand new building, I mean, what we're recommending to all farmers, the cost comes out comparably the same, is to actually pressurize the system up. So outside the building, 1,000 litre header tank, 10,000 litre header tank for 1,000 pigs. The beauty of having the tank outside is you don't ruin your airflow inside your building. A pump house with a 100 litre pressure vessel and a small pump to pump into the building. And then the world is your oyster in regards to which type of machine you choose or elect to put in there. It can be a select dose of 640, or it can be a dosatron, or it can be a medicator. What I would say is very important is actually to have the ability to record how much water your pigs are drinking on a daily basis. That side of things allows you then to keep track much like the poultry industry, is that batch drinking the right amount of water on a daily basis to what you expect it to be? It can tell you about health. It can also tell you if actually your water lines are starting to block up or anything like that. It gives you an early warning about the health of those pigs and the health of your building and water lines in there. I don't know if you've got any more to add on that one, Nigel?
No, I don't think so. I think that's all good common sense and useful advice, Mark.
Okay, thank you. Okay, so the next question we'll ask Nigel. Red Tractor asks us to test our water. What should we do with the results?
Yes, this is a good one. As you say, Red Tractor does ask you to test the water. Actually, as we mentioned in the webinar, when you go about it, test at both temperatures, 22 and 37 degrees centigrade. What you're looking for is what levels of contamination do you actually have of TVCs, and where do they sit within the recommendations. If they're very high, then you need to start thinking about doing things to reduce the levels and get them down to safe levels. If actually your water quality is very good, then really the purpose is keep monitoring it. And then if you start seeing levels increase, then start asking yourself, why is that happening? Is something going wrong? Especially if you're starting to see poorer growth or poorer health within the animals. So really the key thing, the start point is monitoring, well, making sure that the water you've got is of good enough quality, and then just monitoring to ensure that you maintain that good level of healthy water for the pigs.
Okay, thanks, Nigel. We've now got one for Mark. Mark, what are your thoughts on acid against a cleaner and water intake?
Someone's sent me a loaded question here. Can you see my screen?
No, but I can move it onto your screen. Bear with me a second. I will give you control.
I've just pulled up a little graph. I received this a couple of days ago. As I said, we're looking at acid and Huasan, and this is comparable data. Now, to be fair, I haven't got any data in regards to FCR, daily live weight gain, or anything else. But you can see down here, this is day 1 at weaning. Single source pigs into 2 sheds. Identical sheds in regards to both pressurized systems, both 50 pigs a pen, both the same type of drinker. The orange line is the pigs on acid, and the blue line is the pigs on Huasan. This little point here, this dip, was actually scour. So we had an enteric disease hit, and that really came from the breeding herd, in all honesty. Every time we weaned that herd at that point in time, this is 6 months ago, we were seeing a problem with enteric disease. That's now sorted, but you can see we immediately hit with medication and we started to get the pigs back on track. Don't quite understand what these peaks are, peaks and troughs on the orange line, but as you can see, for the first 3 weeks, we put acid in the water, which would be around here. I think we would have withdrawn it. But what we found interesting was, one, the pigs didn't seem to like the palatability of this acid, and I'm not sure what brand it was. But it actually had an effect right the way up to this point, that it was as if the pigs had maybe habitually got to drinking less water. As I say, we haven't got an FCR, we haven't got a daily live weight gain, but what we have got is this point here. This week is week 15 where we finish. The pigs that were on Huasan are actually going to slaughter. The pigs that were on acid right at the beginning, we're not looking to slaughter those for another 10 days approximately. They may end up with the same food conversion ratio. Mortalities are very similar in both sheds. So all of that might be the same, but actually what is looking to happen is that maybe the clean water has actually got the pigs to slaughter maybe a week in advance of the others. A bit similar to the 19 mil water line. So is the acid actually restricting the water because of the flavour? I don't know. Early days yet. We'll be rerunning this trial, and to be fair, I'll be tweeting it out as well as we go along. Once we get the data, I'll tweet it out for anyone if they do Twitter, so it becomes public knowledge for people. Hope that's maybe answered that question a bit, and I'll hand you back to any other questions.
Lovely, thanks, Mark. Okay, we've got 2 more that I've got in to ask. So if anyone's got anything they desperately want to ask Nigel or Mark, if you can send it to us now, then we will try and ask that now. Let me just grab the screen back. Okay, so Nigel, what should I ask my acid supplier?
Okay, thanks, Miriam. Yeah, first of all, actually discuss with your vet what it is that you're trying to treat, or what is it you're trying to achieve, and then that will give you an indication of which potential acids you should be looking at. Then the next stage is actually to look at your water sample results, not just for TVCs or bacterial microbiology, but also the minerals. So have the water tested for its mineral contents, and then and with those results, you can then go armed with this information to your supplier and say, this is my objective, this is what I'm trying to treat, this is my water, and then make sure they can then advise which acid or blend of acids are actually required and which are compatible with your water and also with your objectives and the rate that you need to apply them. So there's a little bit of homework to do before you go, and don't just think, oh, everybody says add acids, let's add acids. We need to just do it correctly, and then we'll get the best results and see the benefits as Mark was showing.
Okay, thanks, Nigel. A couple of questions have come in now. I've prompted you. So we've got a question here. Doesn't water flow data need to be recorded at the same time every day? Who wants to take that one?
I'll take it. In a perfect world, absolutely. I know with the select doses, you can, and I think I shouldn't be advertising really, but you can get a general alert bit of kit. I think it's coming in at about £250 that goes onto the select doser. You can then have a text service, I think it is, texting you daily exactly how much water the pigs have drank. Importantly, it is a text I think that's fired out at about midnight. It's amazing how much difference the pigs will drink. If you think you're going to write that number down every day at 8 o'clock, you never do. Sometimes it'll be at 8, sometimes it'll be at 8:40, etc., etc. Those pigs can drink quite a lot of water. And if they start going ill, you're only looking at a drop of 3%. So they can do that in that period of time that you maybe are not quite getting it, if you like, at smack on 8 o'clock in the day. So I would say, yes, it's a small investment. But actually, if you can spot your pigs going ill sooner, you can actually reduce your antibiotic use because you're getting that problem nailed much sooner before it becomes a major problem in your sheds. I don't know how you feel about that, Nigel.
Yeah, no, I'd agree with that, Mark. It is important, as you say, a short difference in time can make quite a big difference in the results and can be misleading. So yes, they're creatures of habit, so you need to be a creature of habit when we're trying to monitor what they're doing.
Okay, another one for Mark. Mark, what if you, sorry, let me just read this. What if you have a product that needs to be dosed at a specific rate? Which doser would you recommend to dose any unusual rate?
I would use the select dose of 640. What you can do as you program that is you can increase or decrease the dose. You can speak to the actual people who produce it and have a specified dose in there. So it will do anything. We do it from 33 to 1 right the way through to 25,000 to 1. Most of our doses are put in at 100 to 1 through to 500 to 1. And then we can basically choose 100 to 1, 200 to 1, 300 to 1, 500, 700, and then add 20% or minus 20%. So it gives us a whole range with a calculator of what you want to dose. Importantly, there's quite a few liquid products now on the market, and you might actually want to dose that at, say, 250 to 1. So you can dose it direct in your line. Anyone who knows some of these products, the minute you mix them with water, they seem to crystallize out or emulsify out. The select doser, you can actually dose at the right level by just sticking the tube straight in the bottle and direct injecting it into the pipeline. We have checked it with looking at pipelines that are clear to see what happens, and it seems to go down the water lines absolutely okay without actually precipitating out like it does in your header tank or a mixing bucket. So that's what I'd say. Of course, I'm sure other people have totally different opinions to me.
Thanks, Mark. Hopefully that's answered that question nicely. So I've got 2 more questions I'm going to ask before we wrap up, as we're about to take over to 7 o'clock now. So the first one I'm going to pose to Nigel. It was mentioned that medicated feeds were stopped and switched to medicating water. Was this to actively treat the batch or a prophylactic measure?
Okay, thanks, Miriam. Yes, this change has really been driven by legislation and to stop the prophylactic use of medication products, but it gives us huge opportunity then now to be more precise, dosing actually just the pigs that we need to dose, so we can go very easily on pen to pen level if our water system is so designed, and we can ensure that because the feed and the water consumption are related, then we know that the pigs are getting the correct quantities of medication. So yeah, it's a bit of both. Thank you.
Okay, lovely. And then the final question for you, Mark, probably quite a quick one for you to answer. You said that we need to clean header tanks regularly. How often is regular?
Have I just disappeared? If you can hear me, how often? We try and do it every batch, minimum of once a year.
Okay, lovely. I thought that'd be a quick one. Okay, so that's all we've got time for tonight. Thank you very much to Nigel and Mark for their time this evening. I think there's been a lot covered and something for everyone to take away, I'm sure. Also, a big thank you to everyone who's been listening tonight and asking questions. It's been a great turnout. So I hope you enjoyed the webinar. As Nigel's already said, it will be available to watch back on YouTube in a few days' time. You'll receive an email with the link to that. But otherwise, I'd like to wish you all a lovely evening and a good night. Thank you very much.